let's look into fixed size arrays, declaring and initializing fixed size arrays, also the demo of these fixed size arrays. So these are typically declared as like int, the name of the array, and the range, like the number of bits. This means it takes a 16 integer values. Typical C style is just declaring it as data type, name, and in the brackets you will be mentioning the size of that fixed array. So we have also the multi-dimensional declaration. Multi-dimension verbose declaration is this way, like this is having 0 to 7 bits, means typically 8, and this is 0 to 3, typically means 4. So this is compact declaration. And if you want to set the last array element, you can directly access like this, like array 273 is 1. If you want to access set the last array element. So you have this unpacked array in System Verilog. You have this unpacked array. So the typical declaration for this unpacked array is this array have 3 elements which holds each of 8. So the structure looks something like this: b underscore unpack of 0, b underscore unpack 1, b underscore unpack 2, which have these words. Here you will have this 7, and similarly for this. So all the space goes into unused part. All the space goes into unused part typically. So simulators generally store 4 state types such as logic and integer in 2 or more consecutive words, and using twice the storage as 2 state variables. And one more thing worth noting here is if your code is accidentally trying to read from an out of bounds address, System Verilog typically will return the default values for these 4 state variables, 4 state types such as logic. The default value is don't care, and for 2 state values it will be 0. The default value will be 0, logic 0. This applies for all the type of arrays like fixed, dynamic, associative, queue, and also if the address has an.
Now let us see the example of unpacked array. So let me declare the name the. So let me name the module name. So this is basically declaring 3 element unpacked array of 8-bit values each. Three element unpacked array, 8-bit values. Let's try to assign values for each of them. Here I am trying to assign an hexadecimal value. Hexadecimal value of 8 bits. Yes. Now let's try to display the values of each of them. try to copy this one more time. I think we are good to go. So let's try to end this block. Before this, try to call the finish. Let's run this and see what the output might be. So here you can see each of these like 3-element unpacked array of each 8-bit value is taking these values. You can also access the elements in a loop. If you want to do that, we can simply do this like this using a for loop. So we have 3 elements. You can simply do this as well if you want to access the. Let's try running it again. So here you can see again the values, 3 values were displayed. So this is the demo of this unpacked array example.